Unit 1, Test 1 review. At the start of the test here, you are asked to determine if the numbers for 1 through 10 are rational or irrational and explain why. So these will be worth 2 points each. Please remember that numbers are rational if they can be written as the ratio, the first 5 letters here, ratio of 2 integers. And irrational numbers cannot be written as the ratio of 2 integers. So if we take a look at number 1 is 23. 23 is known as a natural number, a whole number, an integer, and therefore is rational. So it is rational, and you can either explain that it's a natural number, whole number, integer, or you can simply say it is the ratio of 2 integers. So remember that we can make any whole number a ratio of 2 integers by putting it over an understood 1. For number 2, we have 0.67. If we put that in our calculator and try to turn that into a ratio of 2 integers by hitting math, enter, enter, we get 67 over 100. So therefore it is rational because it is the ratio of 2 integers. You could also say that it is a terminating decimal. That would also be appropriate, a terminating decimal. For number 3, it is a integer because integers can be both positive and negative whole numbers. So therefore it is rational, and you can say it's an integer, or you can say it is the ratio of 2. It can be written as the ratio of 2 integers, as in negative 82 over 1. For number 4, we have 3.333 with an ellipses. Remember that this can also be written as 3.3 with a vinculum. So ellipses indicate that it does not terminate, so it is non-terminating. But we notice that because we do have repetition of the 3's after the decimal, that it is a repeating decimal. So we can say that that is rational because it is a repeating decimal. Or if we were to try to turn this into a ratio of 2 integers, we could type in 3.3 with 3 going all the way across the screen, hit math, enter, enter, and we get the fraction 10 thirds. So 10 thirds is a ratio of 2 integers. So if you're going to say ratio of 2 integers, make sure you show what fraction that is. Negative 21 is like number 3. It is a integer. Or again, you can say ratio of 2 integers. Number 6, this is a natural number, which is also a whole number, which is also an integer, so it is rational. So you can say it's a natural number. You could call it natural, whole, an integer. Any of these would work. Or you could simply say ratio of 2 integers. Number 7, this is a non-terminating decimal, but also we notice that there is no repetition. This is when it is irrational. So it is irrational because it is non-repeating and non-terminating. So you need to either write non-repeating and non-terminating, both words, or you can say cannot be written as a ratio of 2 integers. I just want you to have both options. You do not have to write all of it, but you need to either write non-repeating and non-terminating, or you need to write cannot be written as a ratio of 2 integers. Number 8, again, this is a rational number because it is natural, it is a whole number, it is an integer or a ratio of 2 integers. So I'll just put up here natural. Number 9, 2.52 is a decimal that terminates. It stops here. So let me put that in the blank. You can say it's rational because it is a terminating decimal. Or if we were to try to type that in our calculator as 2.52 math, enter, we would get the ratio 63 over 25. So we can put 63 over 25, ratio of two integers. Ratio of two integers. For number 10, negative 414 is still a number that we can find on a number line. It can be written as a ratio of two integers by putting it over 1, but it is an integer. It is not natural because it is negative. It is not whole because it is negative. So you can either learn these terminologies, like call it an integer, or you can simply say, I can write it as a ratio of two integers. So basically, again, it can be written as a ratio of two integers, or it cannot be written as a ratio of two integers, if you want to make it real simple and just give one of those responses. For the next section, this is on sum and product rules of rational and irrational numbers. The first thing I'm going to do is label each one of these with an R or I, based on if it is rational or irrational. If it is the square root of a non-perfect square, it is irrational. 0 is a whole number, which is rational. Pi is irrational. Square root of a non-perfect square, irrational. This is a natural or whole number, so that's rational. And 1 over the square root of 3 is irrational because square root of 3 is a non-perfect square. Your job here is to illustrate that you understand your product and sum rules by filling in a number from this selection that makes it true. So I'm just going to write up here that we are taking an irrational number and we are adding a number to make it rational. So if you recall, if we end up with a rational number, that rational number should be 0. The only way to take an irrational number and get 0 is if we add its opposite. So I'm going to choose negative square root of 3. Now all of these we should be able to type in our calculator and make sure that they are rational or irrational. So if I type in the square root of 3, hit the right arrow to get out of the radical, and then add negative square root of 3, and hit enter, I get 0, which is a rational number. So we should choose negative square root of 3. For number 12, I'm trying to multiply an irrational number times a number to get an irrational. So if I take an irrational number and I multiply by a rational number like 0, the square root of 3 times 0 would equal 0. Well, that is not irrational. If I choose negative square root of 3, let's type it in. So I'm trying to multiply the square root of 3 times, let's try that again, square root of 3, hit the right arrow, times negative square root of 3. We want to see if we get an irrational number. Oh, goodness, I forgot my multiplication sign. Let me try that again. Square root of 3 times negative square root 3, and that gives us negative 3. Well, that is rational, not irrational, so I want to try something else. We already said that if we multiply by 0, we get 0. Let's try pi. The square root of 3 times pi. Pi is located again above the caret key, so we hit second and then that caret key to get pi. When I press enter, that is definitely an irrational number. We know of no terminating decimals that have 9 decimal places. And so we make the assumption that if it goes all the way to the edge of the screen without a pattern of numbers here behind the decimal, that it is irrational. So I'm going to use pi. Other options you might have chosen, if you were to multiply the square root of 3 times, and let's check this out, square root of 3 times square root of 3, if we multiply it by itself, we get the square root of 9, which is equal to 3. So that would not work. If we did the square root of 3 times 1, that would be irrational. So you could have chosen 1. If we did the square root of 3 times 1 over the square root of 3, that would equal 1, so we also could not choose that. So the only possibilities we have are the square root of 3 times pi or the square root of 3 times 1. So you could have chosen either of these answers to make that true. Next, we're trying to multiply an irrational number times a number to get a rational. So this is the rule, the exception to the rule where there are two cases. If you multiply a non-perfect square root times a non-perfect square root and get a perfect square root, then it will be rational. The other case is if you take the irrational number and multiply by its reciprocal. Then you end up with the irrational number over itself, which equals 1, which is rational. So these are the two cases. So we should multiply either by another non-perfect square or its reciprocal. So if I look here in my list, a non-perfect square would be negative square root of 3. And remember, we multiplied that earlier. Square root of 3 times its opposite here gave us negative 3. So that was rational, and that's our goal. We could have also chosen the square root of 3. We talked about that also. The square root of 3 times the square root of 3 is 3, which is rational. Or we could have chosen its reciprocal, which would be 1 over the square root of 3. Because when we did that, that gave us 1. So either of these three would be correct. For number 12, either of these would have been correct. But for number 11, only this would be correct. And lastly, we're going to talk about our laws of exponents problems. In this case, we are dealing with a quotient, which means we are dividing. So the first thing we want to do is simplify our numbers here if we can. So negative 10 over 2, if we need to type that in the calculator, we can, but we get negative 5. Any integer we get, if we don't have a fraction, it's going to go in our numerator. Then we need to evaluate our a's here. If we have 6 a's on top and 3 a's on the bottom, 3 are going to cancel, leaving 3 on top. So remember, we can also cross it out and subtract 3. For b's, it is larger on the top, so I keep my b on the top, and then subtract the smaller one from the larger. So if I subtract 7, that gives me b to the first. I do not have anything left in my numerator because 2 went into negative 10, negative 5 times. So my answer is simply negative 5a cubed b. For number 15, we have encouraged you to simplify on the inside first. However, I feel like this one, because as negative exponents, it may be a good one to just go ahead and evaluate our power rule, using our power rule. My recommendation would be to take this fraction and raise it to the second power in your calculator first. So if I type in 4 divided by negative 3 squared, I get a decimal, which when converted to a fraction is equal to 16 over 9. That means in my answer, my fraction is going to be 16 over 9. I have already evaluated it. I am no longer going to raise it to this power. I am done evaluating that. At this point, I'm going to use my power property and multiply all of these exponents. Power to a power, multiply. So on my numerator, I get x to the negative 8th, y to the 12th, and my denominator, x to the 8th, y to the negative 4th. At this point, I want to move anything that has a negative power. So I am going to cross out my x to the negative 8th and put it on the bottom as x to the positive 8th, and cross out my y to the 4th and put it in my numerator as y to the positive 4. Now, we've already got our 16 over 9 down here. When I multiply y's, I add their exponents. So I'll have y to the 12 plus 4 makes 16. And in my denominator, I am multiplying x's, so I will add their exponents. So we will have x to the 16th. Because I've already reduced this number here using my calculator and I have no variables in common in my numerator and denominator, I am through. For number 16, it might look complicated, but it's really not bad. So the first thing I would do is take a look and notice that I have a product, but that each product is being raised to a power. I also notice that over here on the right, h to the 0 exists, so I'm just going to cross that out because its value is 1, and multiplying by 1 will not change the value of the answer. I am now going to put in an understood exponent of 1 for anything that does not have an exponent. So number 5, or negative 5 here has an understood 1. And this 5 has an understood 1 as well. The reason I do that is so that you do not confuse that multiplying the -5 and the 3. We never multiply the base of -5 times the exponent of 3. The only thing we multiply are the exponents themselves. So that means I'm going to have -5 to the 1 times 3, third power. H to the -2 times 3 is -6th power. J to the 9th, and K to the -9th. So that's for this part here on the left. Now when I evaluate this part here on the right, I'm going to have 5 to the -2. H is gone. J to the -8th. K to the -10th. At this point, I'm going to recognize that I have a lot of negative powers, and when I have negative powers, I need to move them across the vinculum of a fraction. Please keep in mind that we only move it if it has a negative exponent to make the exponent positive. Notice here for -5 to the third, the exponent is +3. I will not move that. I will, however, use my calculator and type in -5 to the third power, and I get -125. So down here, I know I'm going to have -125. So now I want to take my h to the -6th and move it to the bottom. J has a positive exponent, so I'll leave it. K to the -9th will get moved to the bottom. 5 to the -2nd will get moved to the bottom as 5 squared. J to the -8th will get moved to the bottom. And K to the -10th will get moved to the bottom. Again, at this point, all I have left in my numerator is the -5 to the third, which we evaluated as -125. And I also have J to the 9th, so I'm going to put J to the 9th in my numerator as well. So I'm done with these. Now I want to take a look at my denominator and recognize that I do have this numerical value here, 5 squared. Well, that means 5 times 5, which is 25. I'm done with that. And I do want to list my variables in alphabetical order. So think H, I, J, K. So H would go first. So I have H to the 6th, J to the 8th. And then my K's, I'm multiplying K's, so I add their exponents. So I'll have K to the 19th in my denominator. When I take a look at this, I recognize that both these numbers end in 5, meaning I should be able to reduce. So I'm going to use my calculator and type in -125 divided by 25, and I get -5. Again, if we get an integer, it goes in our numerator. Now I have J's in my numerator and denominator. I need to use my quotient property. My exponent is larger up top, so it stays up top, and I subtract 8 J's. So that means I have 1 left. So -5J will be my numerator. In my denominator, I have an H and a K left. Remember, the 25 went into here. So that's no longer there on the denominator. All I have left is H to the 6th power and K to the 19th. I am done because I have no variables in common in my numerator or denominator, and my numbers have been reduced. So that concludes the key to the test review. Please make sure to go back and rewatch sections that you struggled with. In particular, these laws of exponents, it might be a good idea to write them down on a separate piece of paper and work them out again to practice getting these correct answers. And remember that you can type these numbers in your calculator to help you make better sense of them, okay? Good luck on your test.